If you're watching this video, then you've heard the news. There's a new programming language in town, and it promises to unify the machine learning landscape. It's incredibly fast, and it looks a lot like Python. And I'm telling you, in the next 18 months' time, every greenfield project in the artificial intelligence and machine learning landscape is going to start in this programming language. It's called Mojo, and if you want to stay ahead of what's going on in the artificial intelligence and machine learning space, you need to learn this programming language. Hi, I'm Cameron McKenzie. I'm the editor-in-chief over at theserverside.com, and I'm also the editor of the #1 Mojo programming language newsletter, so subscribe to that. And I've put this journey together for you to quickly get you up to speed on what's going on with the Mojo programming language. I'm going to start off by showing you how to get it installed on Ubuntu. I've got another video that shows you how to get it installed on Windows, but Ubuntu is my favorite Linux distro. I'm going to show you how to get it installed and configured in Visual Studio Code. I'm going to show you how to create the requisite Hello World, of course, because we've got to start there, but I'm going to go much deeper. I'm going to show you the fundamentals of variable declaration in Mojo, show you the difference between the static typing and the dynamic typing features. I'm going to show you how to do conditional statements. I'm going to show you how to do loops. I'm going to show you how to pull in some Python code into your Mojo. And I'm even going to show you how to create classes in Mojo. Oh, did I say classes? Sorry, that was my Java history getting the better of me. We're going to create some structs in Mojo as well. But before we do that, we have to get Mojo installed, and that is what we're going to do next. Now, to get Mojo installed on Ubuntu, it's a relatively straightforward process, but it is a multi-step process. The first step is to install Modular. Modular is the company that brings us Mojo, and we have to install the Modular CLI first. So you can see there's that command right there on developer.modular.com/download. Go there. You may have to go through a registration wall to get to this page, but find that link of the command to run, and then go over to a terminal window and run it, but make sure you run it in sudo, right? Because if you don't run it in sudo, this isn't going to work properly. So it's kind of one thing to just watch out for. If you follow all the instructions to the T, you'll run into a few pitfalls, and that's why I want to kind of point them out to you. Now, the other thing that is required is you actually have to have curl installed as well for a couple of commands. So you might want to make sure you've got that installed too. Now, I'm going to go sudo-I just so that I know that I'm logged in as root. I'm going to type in the correct password this time. And after I do that, I'm going to do a little sudo apt install curl. Just some of the commands require curl. So I'm just going to make sure that's installed. And then once curl is successfully installed, I'm going to copy that command, come over to the terminal window. I'm going to click Control-L just to clear things off a little bit, and click enter. Now, remember, I'm running this as root. So if you're just doing it from a regular count, make sure you're using sudo. I'll click enter. That should bring me Modular, the command line interface. And once this is done, I'm going to try to install Mojo. Okay, and there we go. The Modular CLI is installed, but we've still got to install Mojo. Now, I could see in the log there that Python 3.10 was installed, but I'm telling you right now, there's a good chance that if we actually try and run the next command, which is modular install Mojo, we're actually going to get barked at. And the reason we're going to get barked at is because I don't believe the virtual environment is installed, which is the next thing we'll have to do, something that's just not listed there on the list of steps to follow to get Mojo installed on Ubuntu Linux. What did I tell you? Python 3.10 VNV missing. It's easy to add it. Just do sudo if you're not in root. If you're in root, just follow the instructions. Apt install Python 3.10-venv apt install, double check, click enter, And then once this is done, we still got something else to do before we can install Mojo. Okay, that looks good. I find after this step, I always have to do a modular clean. Okay. If you don't do a modular clean, you end up running into some problems when you try and install Mojo. So issue that modular clean command, and then we can follow the instructions in the page, which is modular install Mojo. So let's go and do that. Modular install Mojo. Okay, and it looks like we're done, but looks can be deceiving. You notice it says enter Mojo to start the Mojo REPL. It says also make sure you run the command above first. So I'm going to copy this command here, paste that below, click enter, and now my environment variables should be set up. Now I've done that as root. I'm not sure if I'm going to have to do that as the regular root user, but I will keep that thought in mind. Now theoretically, with all of that done, we should be able to just type in mojo -- version and look at that, the latest release, 0.6. With that done, we should be able to open up the REPL environment. So we just type in Mojo, and we can just write some code. Now, normally with Mojo, you have to put code inside of a main method. But in the REPL environment, it'll just execute individual commands. So feel free to just type in print hello Mojo on Ubuntu Linux world. Click enter twice, and boom, now it's just printed out the compulsory hello world using the Mojo REPL environment. So we've got Mojo installed, but you know what's next? I want to do some development, and I'm not a big fan of doing development in Nano VI or in REPL. So the next thing I'm going to do is install VSCode. That's next. So we've got Mojo installed, and we've proven that by bringing up the REPL environment under the current username that we're logged in with. So everything's going swimmingly. But let's install VSCode and the Mojo plugin and create a program or two in here. To do that, I'm just going to go into the software app in Ubuntu Linux and look for VSCode. When VSCode comes up, I just click to install, provide my password, and it looks like VSCode is installed. Let's take a look at the status here. Boom, it looks like everything looks good. I'll close that window. I might even close the command window as well, that terminal, clean up my environment just a little bit, and then go over here to apps. And let's see, where is VSCode? Boom, there it is. So we'll click that to open that up. And what do we want to do once this installs? Well, we obviously want to install that Mojo plugin. So I'm going to come over here to extensions, allow it to load, type in Mojo, and there we see that Mojo extension for VSCode. I'm going to click install. And once it's installed, I'm going to give myself a pat on the back. But again, I'm not done yet. I actually have to go over here and configure it. So I'm going to click on that cogwheel to configure the settings for the extension. And the one I want is the path to modular home. And the path to modular home is really, what is it? It is, well, I think it's just $home/.modular, right? That's where it all resides. I think if I actually go over here and look at my home directory and do ls-a, Boom, there you see that modular file right there, that modular component, and that's the one I'm pointing at. Now, by the way, make sure that's there in your home folder, right? ls-a to show the hidden files. If it's not there, the plugin's not going to work. Okay, so I see a lot of people saying, hey, my plugin doesn't work. It's because you've installed everything as root and everything's under the root account. It's not under your personal account. So just be careful with that. Now, I think that is all done. I got my fingers crossed over here. And from here, I'm going to go in and I'm going to start a new project. I think I'll create a new project in a folder on my desktop called My Project because, well, I like to project positivity all the time. So there we go. My project has been created. I'm going to open up that folder. And now that that folder has been created, it's time to add a file or two to it. So I'll click Add File, and what I'm going to do, I'm going to name it hello.mojo. Click Enter. You can see the little fire emoji up there, and it means that the plugin is now working. And from here, I'm going to just write a little bit of code. I'm going to type in def main. Notice that when we work with Mojo, we have a main method in our applications that is trailed off with a colon. No more if name equals main. That's Pythonic stuff, goes out the window when we work with Mojo. And instead, we type everything in this main method. So here I want to do a print. I could say print hello world. Then when this is done, I can click the play button. This is now going to run, and you can see that this prints out hello world. I don't know if I'm in love with the tabbing over here, so I'll fix that up just a little bit and run that again. Notice again, we don't have curly braces when we're working in Mojo. We have indentation representing the scope and the blocks of code that we're creating. So that creates a little hello world method. What else could we do? Well, maybe we could actually go in and, I don't know, declare a variable as well. So I'm going to add a little bit of code here. Everybody's excited about the fact that when we work in Mojo, it's a strongly typed language. So let me actually declare a variable here. I'm going to use let, which declares a constant. I'm going to say let x equal 7's my lucky number today. Almost put a semicolon in there. I was thinking in Java. And excuse me. And now we'll print out x. Okay, let's see how that goes. Printing out x. Boom, all of a sudden 7 shows up there. Now, I know what you're thinking. You're thinking, hey, I thought Python was strongly typed. I thought we had to decorate everything with int and float and string and all that other stuff. And you do. But inside of a method, Mojo will infer the types. Did I say Python earlier? I'll mix them up from time to time. Mojo will infer the type. So let x equals 7. This will just assign the type int to the number. But you can actually do it explicitly. There's times where you have to do it, like when you're declaring properties of a class, struct, or passing arguments to a method. But it's optional here in the code. But I could type in something along the lines of var y colon int uppercase I. I did pronounce it with an uppercase I, but that Canadian accent, you may have missed it. So there we go. We've now declared a variable named y that's of type int, explicitly stated. And now we could do 7 plus 5, x plus y. Okay, there we go. Click play here. And does it work? So first of all, it works. So yes, it works. 7 plus 5, last time I checked, equals 12. However, there's something interesting going on there. Notice it says, hey, y was declared as var, but never mutated. This might be a little different from what you know in JavaScript, but in Mojo, let defines a constant. And var defines a variable. And if you define a variable, it should vary, right? And if you write code and you use var, declare a variable, and you never change its value, it doesn't vary, Mojo gets very mad at you. Because it can do a bunch of optimizations. If it knows something's a constant, it's immutable. It doesn't change. It can do a bunch of things when it's included in list, passed arguments, all sorts of things. So anytime you got a variable that doesn't vary, it will bark at you and say, hey, use let instead. That's the difference between let and var in Mojo. Of course, if we do y equals y times y, boy, this sounds like a first-year philosophy class, right? Y equals y times y. I don't know, now print out y. Boy, again, print out y. Boom, all of a sudden we get the number 25 printed out. So there you go. That's how you do some basic variable declaration in Python. But it gets more interesting. Why don't we actually take a look at calling a method in Python? That's what we'll do next. So there are times in Mojo where you have to explicitly declare your variables. One of those times is when you create methods. So let's imagine here we had some program where we were calculating the area of a square, right? So maybe we would have a method, and that method would be, I don't know, maybe called calc area. Okay, calc area sounds good. And in order to calculate the area of a square, we would need the height of the square, right? So height, and we'll make that an int. So when you're working with Mojo and you define methods, when you pass variables in, you have to define the type that they would use. So height has to be an int in this case. Another interesting thing that I use here is fn. If you use def, which Python programmers will be familiar with, you can write sloppy, unsafe Python code in that main method. Any standard Python code can go in there. And you don't have to obey the rules of Mojo. With fn, we assume strict typing and safe operations. So to get the most out of Mojo, you want fn methods, but def will work in order to support legacy Python code. So here we've used fn. For that matter, up here, we could have changed that to fn as well, because we're doing everything strictly by the book here. Now, for this particular method, it should generate a number when it's done, right? The area. So let's throw in a big arrow there and say that an int is going to be returned. So we've got a function called calculate area. It takes the height of a square, which is of type int, and when this is done, it returns an int to the calling program. And then we just implement this thing. So how do we do it? Well, let's return height times height. I'm sure we could use some math power operation there to do that, but we don't have to get complicated like that. Just return height times height. And if I wanted to do a little print and calc area on y, that should work. And I could also do a print calc area on x. I'm nesting these methods in here, so it's getting a little tricky. But you get the idea here, right? We've got methods. We're calling them inside the print. We're going to print out what the height of a square that is 5 units tall is, what the height of a square that is 7 units tall is. We'll click Control S, click play, and look and see that it says, well, okay, the one that is size 7 is 49. I did forget that we multiplied y by itself and then passed the result of that into the calculator. So now we're getting a massive square here with 625 units allocated to that. I don't want to see the tax bill for that one. But there you go. You get the idea, right? So now we are passing variables into methods and creating methods of our own. The other thing that you'll notice is that the main method is above the method that's called, right? with Python, the order of appearance of methods becomes important. Here, it's kind of like Java. It's kind of like C++. The order doesn't actually matter. Now, by the way, one other thing that is worth mentioning is just the scope of the variables. You can actually declare variables outside of a function here, although all of the executable statements have to go inside of a main method. But you could say, let y colon, not y, z colon int equals 12. And then down here, we could actually say something like print z. So that will work. And that will work because the way scope works in Mojo is that it's block scope. So any block that's defined by indentation, a variable defined inside that block or a parent of that block, that variable is accessible. So a variable is accessible inside the block in which it's defined, any subblocks. So here, the variable 12 would be available inside this method simply because it's declared outside of the current block, and that block can get into it. So if I click run there, boom, all of a sudden we see that variable z being declared. I might show that again a little later when we start doing conditional statements and loops. And hey, why don't we do that next? Okay, why don't we just take a quick look at, say, conditional statements and loops, right? Because all of your programs are really just data through variables, conditional logic, and doing it really fast through loops. So I'm going to come over here. I'm going to add a new file, and I'll call it loops.mojo. By the way, you can actually make a fire emoji the extension of the file. I'll come in here and I'll do fn main, which you're going to find is very compulsory. And let's declare a variable. Let x be equal to the number 0. And let's write a program that'll just check to see if that's negative, positive, or 0. Right? So we'll do some conditional statements. And if you're a Python programmer, this is going to look super easy. And if you're a Java developer or a C++ developer, it's not going to take long to figure it out, right? So if the number is less than 0, what do? We print, hey, it is negative. And then what if it's greater than 0? Well, we can use the good old elif syntax here. So else if x is greater than 0, what can we do? We can do a little print it is positive. And I think I spelled that wrong. So elif, that looks better. And then finally, we'll throw a little else in and we'll print out, hey, it must be 0, because if it's not positive and it's not negative, then it must be 0. Come down here and click Control L to clear things out. We use let, which defines it as a constant, so we shouldn't get barked at. I'm going to click Run, and you can see here, hey, it must be 0. 0, let's fix that. But if I change that to the number 1, boom, all of a sudden it says it is positive. And if I throw that -1 on top of it, it says it's negative. But I don't want to do that. I want to finish this on a positive note. And there we go. We say it is positive, and everything about Mojo is positive. And now, another thing I wanted to do was maybe just show you a loop. So that's a condition. Well, the file's called loops. I put a conditional in there. Let's put that loop in here as well. If you are a Python developer, this will look very, very familiar to you. So we could do something like for number in range, for num in range from, I don't know, 1 to 11. What do we want to do? Well, let's say if the number modulated by 2 is equal to 0, then we'll print out the number. Looks like my braces are getting all mixed up here, but trying to keep up with it. I got everything match 1, 1, 2, 2. I think I got an extra one there, so we'll fix that up. And then we'll print the number if mod 2 is 0. So I don't know, is that going to work? Does that look good? I don't see any squiggly lines. Let's click play, and there we go. It looks like it's printing things out. I see the 6, 8, 10. There's 2, 4, 6. So boom, everything seems to be working well. Now there's actually something that's super cool in Python. If you've got a loop, you can do something called unrolling it. So you can put this unroll decoration in front of a loop. So you can say for I in range, I don't know, range 5, and then do some serious operation on I. Now I don't have a method called serious operation, so work with me. But just imagine you had that method that did some serious operation. Normally that would run 1, 2, 3, 4, 5 times inside of a loop. If you put that unroll annotation there, when the code gets generated, compiled, put into the build, it'll actually change that. And instead of doing a loop, it will actually just change the code so that the code says serious operation 1, 2, 3, 4, 5, right? So behind the scenes, it's actually going to change the code. It's going to unroll the code so that we don't have looping structures. It actually just has individual commands that could be executed potentially across multiple cores, giving you increased performance. So that's this little decoration that you put in your code, Unroll, which can provide some hints to Python on how to optimize your code in the future. So just something kind of cool about Python there. Anyways, that's some neat stuff. That's variables, conditional statements, some loops. Let's finish this off by just looking at some of the object-oriented stuff and how you can create essentially a class for a structure in Python on Linux. Okay, before I slam you to sign up for my newsletter or buy some of my books, I'm going to do one more thing here. I just want to show you some object-oriented type stuff in Mojo. So over here, I'm going to go into my project and create a new file. And what am I going to call it? I'll call it square.mojo. So with the file created, I'm just going to come in here and create a new struct, and I'm going to call it square. A struct is essentially the same as similar to a class in a Java, component class in Python. Every square has a height, so I say var height, and I specify the type. It's of type int. We need a constructor, so I'll say use the underscore init. Pass in the reference to itself, the object self component, and then I don't know, we want someone to pass in the height, which is of type int, and then inside the function we'll just set the square's height, self.height, equal to what was passed in, which is h. So that all looks good to me. Oh boy, the auto assist there is coming down on me. And then of course, every single square should have a calc area method. And all we need is a reference to itself. And we need to specify that this is going to return an int when it runs. Let me just do the return, right? Self.height times self.height. Make sure I've spelt that all correctly. I got my colons in the right spot. I've got that declared. Oh, there we go. It's uppercase I int. Almost made a mistake there. Now all this looks good. Now I've declared a component of structs similar to a class. Its name is square. Every square has a height. Every square can be initialized by passing in one value. the height of the square. And every square can calculate its area through the calc area method, which returns an int. Now I could just use that inside of my code. I could say fn main, and in main say, I don't know, let's create a square peg. Square peg, square pegs, square pegs. Let peg equal square, and square 5, I guess. And then let's print out the area. So print peg.calc area. And there we go. Everything looks good. I'm going to give myself a little bit of room here over on the output window. I'm going to do a little Control L to clear everything up. Click Run. And there we go. Our square that has a height of 5 prints out to indicate that it's got an area of 25. So that is pretty awesome. Now we're starting to work with components, classes, structs in Mojo. The language is getting really, really interesting. Okay, there you go. That was your whirlwind tour of Mojo. And again, I don't want you to think that was an introduction to programming with Mojo. That wasn't a Mojo programming course. That was just how to get it installed, how to get the ID up and running, and just a quick look at how things like variable direct declarations happen, how you can create methods, how you can do loops, how you can do conditionals, and maybe even introduce some of the object-oriented concepts to you. But this was not a programming tutorial. I will tell you, I've got some programming tutorials, so check them out on YouTube, where I go over these concepts in much more in depth, and I'm continuing to update all of my tutorials based on all the new features that come out with every release, which is a lot. If you want to keep track of it, sign up for my newsletter. The link's in the description, because you really want to keep on top of Mojo. This is the future. A lot of people missed out on the AI revolution. This is the next big thing that's going to happen in this space. So get ahead of it, or you're going to be left behind. A couple other things I would mention. I've written a couple of books. One is Pickering is Springfield, is all about the Simpsons. I've written a couple of Java books as well, which may or may not interest you. And I've also been working with a young freelancer over at the server side named Darcy DeClute, who wrote the Scrum Master Certification Guide. So if you're doing Scrum, or you know somebody that's doing Scrum, follow her on Twitter and Instagram and YouTube, and pick up a copy of the book, because it'll get you certified and look fantastic on your resume. As far as I'm concerned, please subscribe to my YouTube channel. Also worth mentioning, I'm the editor-in-chief over at theserverside.com. We got lots of great tutorials on Mojo, Python, DevOps, Git, Scrum, Agile, you name it. So head over there and check out what we're doing over there. Sign up for my newsletter, follow me on Twitter, do all of those things. And if you're watching this on YouTube, subscribe, because there's going to be a lot more great information about Linux, Ubuntu, Python, AI, data science, and machine learning coming up in the very near future.